Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to go through one of the questions in the past year paper of Physics 0625. We'll be going through paper 4, winter 2023 paper, question 3, which is a question from a pressure topic. So question 3 goes like this. Liquids are difficult to compress, whereas gases can be compressed easily. A. Explain in terms of particles why it is difficult to compress liquids. This is a 2-mark question, so you need to include 2 key concepts in your answers in order to fall full marks for this particular question. The question has already specified that you have to talk about the answer in terms of the particles. So what is so significant about the particles in a liquid? Now, the liquid particles can move a little bit more freely in liquids, but they are still quite close to one another, even though they are further apart than in solid. So the fact that the distance of the particles are so close to each other is what makes liquids so difficult to compress. So that's one of the things we're going to write in our answer. So liquid particles are close to one another. So make sure that you mention something to the effect of how the distance of the particles are quite small. Now, because the distance of the particles is so small, one of the things about particles is that when you try to push particles together, they actually try to push away from each other because there's a certain distance they like to keep away from each other, which means there's a force of repulsion. So that's one of the things we are going to write. So because they're so close to each other, the force of repulsion can actually be quite high. So that's the second answer we're going to write. The forces of repulsion between the particles are high. Now, let's check the answer against the mark scheme. So, based on the mark scheme, as you can see, first of all, we need to talk about how close the particles are to one another. And secondly, we need to talk about the forces between the particles. So even if you didn't know it's called forces of repulsion, you can just mention forces, you would still get full marks. So because we got this correct, I'm going to just give 2 ticks to indicate I got both correct here. Let's move on to B. Figure 3.1 shows a rectangular block floating in water. The density of the water is 1,000 kg per meter cubed. They've given us a diagram here drawn very nicely to show how the rectangular block would be like within this water. The area of the base of the block is 0.014 meters squared. The base of the block is at a depth of 0.087 meters below the surface of the water. Number 1, show that the pressure due to the water at the base of the block is approximately 850 Pascal. Now, as you can see, this is a show question. So when you want to solve show questions, you cannot start with the number that you are given. You have to assume that you didn't know what this answer is, so you start answering from scratch, and the final number you get should be the number you're trying to show. So what are we supposed to calculate? We are supposed to calculate the pressure due to the water. So this means the water pressure. So because water is a liquid, we're going to use the liquid pressure formula, which is P equals rho GH. So rho is the density of water, which is given to us in the question. It's 1,000. And G is the value of the gravitational acceleration. Now, this value has already been given to us on the cover of the exam paper. So we're just going to backtrack to the cover. So you can see they've given us the acceleration of free fall is 9.8 meters per second squared. This is G. So we're going to use this G value in our answer. H is the depth at which we're calculating the pressure. They've given us the base of the block as 0.087 meters, and that's also in the diagram. So that's the number we're going to use in our calculations. So when you calculate this number out, so if we were to calculate this number out, we would get 852.6 Pascal. It's not exact, but it is approximately 850 Pascal. And there we go. We've proven this. Let's quickly check against the answer in the mark scheme. And as you can see, we got the formula correct, and they've also got a value of 852.6 Pascal, which is approximately 850 Pascal. There we go, we got this correct. Let's move on. Number 2. Calculate the force F on the base of the block caused by the pressure given in B1. Now, even if you didn't know how to solve number 1, you can still get the answer correct for number 2 because they want you to use the pressure given in B1, and that value is in the question, 850 Pascal. To solve this, you need to use the formula that relates pressure and force. And this formula is P equals F over A, which is pressure equals force per area. The pressure is already given in the question, that's 850. F is unknown, while A is given in the question here as 0.014. So to solve this, you need to take 850 times 0.014. We don't use the value of 852.6. Not to say that you can't, but since the question has already given us the value of the pressure as 850 Pascal, just take that to solve the question, because then you're going to get the correct answer for sure. So to solve this, 850 times 0.014, and that gives us a value of 11.9 Newton. Now remember that in IGCSE, we can write the answers to 2 or 3 significant figures. In fact, 2 significant figures is preferred, as you can see from the mark scheme. That's why the value given in the mark scheme is just 12. So we're going to follow the preferred method in this case. So instead of writing 11.9, I'm going to round this to 2 significant figures, which is 12 Newton. Comparing our answers to the mark scheme, we got 12 Newton, which is correct. So when you get the correct value with unit, you would get the full marks for these calculation questions straight away. Only if you do not get the correct answer only if you don't get the correct value with unit, then the examiner has to check, have you done the working correctly? Did you write the formula out? Did you write the correct substitution out? If you did, then you'd score at least 1 mark, even if your value was incorrect. Let's go on to number 3. Force F is equal to the weight of the block. Calculate the mass of the block. So we're going to take the value of the force from our answer in B2. So how do we solve this question? They've told us that force is equal to the weight, and we need to calculate the mass. So you need to use the formula that relates weight and mass. This formula is W equals mg, where W is the weight and m is the mass. They've told us that the force F is equal to the weight. We've already calculated force as 12, so we're going to put that in our working. M is mass, which is unknown, and G, as we have already established, is 9.8. So when you calculate this out, you should get 1.22. Well, 1.22 kilograms as the mass. So because we want to write it to 2 significant figures, we're going to write the answer here as 1.2 kilogram. And as you can see, our answer is the same as the mark scheme. So remember, you only get the full 2 marks if you wrote the correct value with the correct unit. If in the event this was wrong, then the examiner will look for the formula, which we did, right? W equals mg, and we also had the correct substitution here. Now to get the correct answer for the mass in number 3, it does depend on whether we got the correct answer for the value of F in number 2. The problem is, what if we have calculated the value for F wrongly? Now obviously, if you had calculated F wrongly, you would get a different value for mass as well, because that substitution would now have been incorrect. Now normally when it comes to calculations in IGCSE, there's a concept called error carried forward, or ECF for short. What ECF here means is that obviously if your answer for the following question depends on the previous question, if you scored the first one wrong, the second one would also be wrong. But if you had calculated correctly, then ECF applies. That means if F was wrong, but you used this number correctly in the calculation, the value for the mass, even if it's not the same as in the answer scheme, but you calculated it correctly with your wrong value, you can still get full marks for the following question, even if the answer is actually different from the marks. So that's what ECF means. So you don't have to worry about, oh no, I'm going to lose so many marks. Just try your best to make sure you use the correct formula and get your workings correct. And that's how you solve question 3. Do check out my channel to find out how to solve other questions in the past year papers.